Yeah, good everyone. Welcome to my channel. In today's video, I'll be talking about the basic structure of programming, the basic structure of software programming, and the time and big annotations applies to each of them. So obviously, checking my screen, checking what I have on my screen. I have the sequence, which is the first which is the first basic structure of programming. The second one, which is the loop. The third one, which is theory. Sorry, I said the third one. I said the third one. Third one is the solution. I will repeat myself. We have the three basic structure of software programming. We have the sequence, we have the loop, we have the selection. So these are the elementary basic structure of what programming. So all these jargons, all these software applications that are running, all these mobile apps, web applications that are running behind what everything is running behind algorithms, and the algorithms that you're seeing that's making those applications, those software to works are these three basic structure of software. Are these three basic structure of what of programming. So I think I've said it well. So I think I have to explain each of them one by one. So yes, any mobile apps you're using, any web applications you're using, any data structures you're using, stuff like that always runs behind. These are the three guys that run behind other stuff you're saying. Is it mobile app? Is it web applications? Is it software applications? Is it automation? This is both. We have so many real applications of software. So and what's made those things to run are these three guys here seeing me you are seeing on my screen here. So let me start with the sequence. The sequence is like, oh my god, I will have to use a real life application to explain what sequence is or does. Sequence is just like you're taking a step, you're taking an action sequentially, one step at a time. Okay, for example, I want to get to shopping mall to get a bread or to get some bread. So I will just take the first step I'll take is moving out of my apartment. That's the first step. That's the first action. Moving out of my apartment, going, taking a bike or taking a cab from my place of abode. Those are the steps, like the actions that I would need to take. They are sequentially, step at a time, one step at a time, step by step process. And this step by step process are what makes an algorithms. So and these algorithms are what makes a software too. So those are the things that run behind the software, that runs behind these applications you're seeing, mobile apps, web applications you're seeing that are running in real life. So I think I've explained that. I think I've explained that one better. So I'll move to the second, which is the loop. Loop is just obviously something that runs repeatedly over time. It might be in a definite set of time or definite sequence of time. So, but it runs continuously without stop until there's a set of instruction that is given to it until a set of instructions is given to you to make it to stop. So I think that's just literal way of me explaining what loop is. So you can have, yeah, obviously in any software programming, sorry, I said software programming. In any programming language, you have so many syntax and basic syntax and structures of how it works. How a software how a for loop runs in Python might be different, obviously, from how it runs on a Java software programming. How a for loop run or a while loop run in a Python programming might be different from how it run in a C++ programming language. So all these things, each of these languages has its way or its structures of how each of these loops runs. We have for loop, we have while loop, we have do loop, we have for loop, we have while loop. I'm not sure we have do loop. Do wise. I think there is do wise too. So these are the ways. Yes, and for another application of how a for loop runs is when you are running a bot. For example, I think that bot is what comes to my mind as a real life example of how a for loop works. Because continuously over a definite period of time, a for loop will always run so you get what you want to achieve something, maybe to trade for you, or to do some automation tasks for you. Those are the ways of you using a for loop, or a loop stuff in a loop example, a loop structure in your what in real application. So let's move to the selection. This selection is where, okay, we have for loop here, we have we have while loop, we have for loop, and yes, selection we have if else here. So if this is true, run the condition, run the action that is here, and if this thing is false, run the else statement that comes underneath. So selection is just just to check for if a particular statement is true or not. If a particular statement is true, run the action that is beneath, or if a particular statement is not true, run the action that follow thereafter. So these are the ways of you. These are the base structures of you building your software application. These are the three guides that will guide you on how to create your algorithms for a web application or for a software application to build. So these are the things you have to put in place. So I need to go through the big goal notations too. So the big goal notations for sequence is always hen, always constant, always hen. But most times big goal notations depends. Most sometimes you might have a single loop. For example, you might have a single for loop inside a code structure. Sometimes I have a nested for loop inside a code structure, inside a code base. If you have in a place where you have like double or nested for loop inside a code structure, this is where the N2 come into play, like N2, and if you have a single for loop, it's always what an N. I mean, in terms of what time, in terms of time complexity of your big O notations. I think I've explained that better. So in the last one, which is selection, is where you have the if an else statement. If a condition is met, run this, and if a condition is false, run the statement or the action underneath. So this part is where how you can apply the big O notation to this part is where it depends on use case. For example, if a statement or condition that is if f is true here, the condition that will run here, the condition that will run here will determine which which time complexity will be given to it. So, for example, if you have a for loop inside this if statement, for example, if the if statement is true, the condition underneath will surely run, and if the condition underneath requires a for loop for it to run, that means we still have to have a single like on, like a single time complexity for that condition for that condition. But if you have a nested for loop inside the condition here, that means you have to have a 0 o into 2 o into n raised power 2. Let me put it that way. So I think if you have any question about what I've discussed, what I've said in the video, I will be love and eager to answer you at the comment section below. Always put your question in the comment section below. Yes, so far what I've been explaining so far is about the basic structure of programming and the big time notation that runs underneath each of these three guys here, which are the basic structure of programming. So I've explained what sequence is so far. I've explained what the loop structure is, the sequence structure, the loop structure, and selection structure. Those are the three structures of what sort of programming. So, and under each of these structures, I give a detailed explanation of what the big O notation is. Yes, so far I've talked about the time complexity. The space complexity depends on use case too also. Space complexity is just to determine how much space each of these variables I use my code structure will carry. For example, if I'm using an integer inside my code structure. For example, inside the sequence, for example, I have a variable called first name equals to inside an air quote Isaac. So, for example, if this what's it called? If this string data type was maybe 4 bytes or 3 bytes, that's just the time. That's just the space allocated to that data type value inside the choosing programming language designed to use for that code base over that structure. So I think those are the ways of you exploring and NSing how this thing works underneath. Yes, this thing will help you out at the long run when you have the knowledge and the base structure of how a software or how an algorithm works underneath. Because when all these real applications you are seeing of software web applications you are using, Facebook, WhatsApp, Instagram, all these real applications, TikTok, they are running what makes those applications run are algorithms, are what software engineers have worked on hours to build on, to work on. And all these web applications, software applications run underneath. What makes it to run algorithms? What some dedicated software engineers have dedicated their time and efforts to make it to work, that people outside the world are enhancing it and using it for their day-to-day lives, and it's making life better. People are making ends from it too. So those are just social media apps. For example, we have other apps that are not into social media. People are using it every day. to improve their lives too. So I just have to make this video for you guys. If I believe some of you guys are outside there that I just curious of how software are built, and how what big notation is, and what's the correlation between the big notations and the big structure of programming. And I believe in this video I've done some rigorous rigorous explanation on how these two correlate and how each of them works differently. So just I believe you love this video, and I hope you like and subscribe to my channel for more videos like this coming up your way. Thanks for watching, and bye for now.